This is Mr. Beck Does Your Homework. This is AP Physics, homework 2.7 on projectile motion, question number 5. During a baseball game, a batter hits a pop up to a fielder 69 meters away. So I know that the ball is going to do a parabola. I know that it's going to travel on level ground to a fielder whose distance away is going to be 69 meters. Okay. The acceleration of gravity is 9.8 meters per second squared. If the ball remains in the air for 6.4 seconds, how high does it rise? So really, I'm interested in this tippy top point. So I want to know this displacement up. So let's see. I've got x world. I've got y world. I'm looking for y in this problem. I know that when it hits that maximum height, that my y velocity, final y velocity, will be 0. I don't know my initial y velocity. I do know my acceleration is going to be g, is going to be negative 9.8 meters per second squared. And I don't know my time, and I don't know my initial velocity. What do I know in the x world? I know that my displacement is going to be, well, actually at that time it's going to be half of this. So I'm just going to write 69 divided by 2 meters, because it's only going half that distance and half the time up to there. My time for both sides, it says the ball remains in the air for 6.4 seconds. Well, that's up and back down again. So how much time will it be just to get to the top? Turns out that to get to the top, it's going to be half of the total time. So my time is going to be 6.4 seconds over 2. So if I've got 6.4 seconds over 2, that for me is going to be 3.2 seconds. So I now know my time here is also 3.2 seconds. So now can I get my height with a final velocity, an acceleration, and a time? Well, I don't really have an equation for final velocity, but I could run this backwards and see how far it falls if it started from initial velocity in order to get down to the ground in 3.2 seconds. So let's do that. Let's set this as my initial velocity. So instead of doing on the way up, I'm going to do on the way down, because it should wind up with the same height, but it's going to be negative. So let's see, my distance is going to be my initial velocity times time plus 1/2 my acceleration times time squared. So my displacement is going to be my initial velocity of 0 times time, so that goes away, plus 1/2 my acceleration is negative 9.8, and my time is 3.2 squared. Now all of this will give me a negative number, but I'm doing the second half of the problem instead of the first half of the problem. They're symmetrical. So falling from this height is going to be the same as getting up to that height. So I'm going to wind up with a negative y, but I'm going to enter it in as positive. Alternately, I could have said, well, I have my time. What is my final velocity? So, sorry, my initial velocity. So if I'm looking for my initial velocity, and I know my final velocity, my time, and my acceleration, then I could say that my final velocity is my initial velocity plus my acceleration times time. Then my final velocity is 0. My initial velocity is what I'm looking for, and I've got negative 9.8 and my time of 3.2. So when I do this, this will give me my initial velocity. So what I could do then is do the same thing that I did up here, but now I can use my true initial velocity times time plus 1/2 gt squared. And here you'll get the height with your initial velocity because you're solving for that here. It might be 0 equals. So now I can actually use an initial velocity and not have to imagine the second half instead of the first half. And this should give you exactly the same answer, but positive instead of negative.